Hey, we got some more vector addition going on here. This time we have multiple uh, vectors that we want to combine. Maybe this is cables attached on to an object, or maybe people pulling on a ropes on a boat or something. I don't know. What it is, it doesn't really matter. But what we're going to do is we're going to solve this out. Now, I don't like to do this in a way that we have to use law of cosines and law of sines and that kind of stuff. I want to stay right with the right triangles. I find it easier and just a lot more fun to do. So first thing we have to do is we have to convert all these weird vectors into x and y components. So we're going to break this thing down. Like I'm going to take this force right here and I'm going to break it down into a y and an x. All right, and I will do that to each one of these. Now I have angles marked in here, so I'm obviously going to do it the easiest way. Now remember, when you're going head to tail, it's actually like reverse head to tail, because we're taking the components and we're making them. You know what I'm going to do? I'm going to switch colors for that, because let's just color code this. It just makes it more fun, and it makes it a lot easier to see when we're done. So again, I'm going head to tail with these components. And we'll break that down there. Ooh, that doesn't look very right, but that is supposed to be a right triangle. Ooh, salmon. Don't see that color very often. And oh, we have a 45. That makes it nice for me. I like the 45s. And we have that. And then finally, let's do some green here. All right, so we have now our vectors have been broken down into 4 different triangles. So what we're going to do is we're going to take in, we're going to find the sides of these triangles, the components of these triangles, the x's and the y's. And so we'll start off with this nice little one over here. I think it was this color. So this was the y, and this was the x, right? All right, so we're going to have a negative x, and we're going to have a positive y, right? To the left is negative, up is positive. Now, how are we going to find that? Well, we know the resultant is 10. We know the big side of that triangle is 10. And we know that the angle is 15 degrees. So I'm going to use sine and cosine to solve for these. Now, I'm going to do the algebra just in my head, because I know that if I take the opposite side here is sine. So if I take 10 sine of 15, that will give me that side. And I'll make sure that's positive. And then going right with that, because I don't want to waste any time, 10 cosine of 15 will be this side. Now make sure that you are in the degree mode, or this is not going to work. Okay, so I'm going to punch these in the old calc. Again, 9.65 or 9.66. Let's just call that 9.7. I like to round a little bit. And we'll do the same to the other side. And that equals 2.6. And there I have my 2 sides of my triangle. Now, I'm going to do that same thing throughout this. I'm going to follow the same pattern. So what I'll do is I'll write the math down, and then I will pause a little bit, and I'll go and I'll put the numbers in so we don't have to wait on me. So we got right here, we're going to switch to yellow. 20 is the opposite is 10, so that's cosine. So it's going to be 10 times the cosine of 20. I'm sorry. I said one thing and I wrote it, so it's the opposite. So 10 times the sine of 20, and then 10 times the cosine of 20. All right, we'll do the same. Oh, we like when we have the 45 degree angle, don't we? So we have 25 times the cos. I am off here. We have 25 times the sine of 45. And this little side here is 25 times the cosine of 45. Now, they're going to be the same answer. Now, notice I have two arrows on the same spot. That's fine. That works out. Just make sure you do the math for both and make sure if they're pointing the same way, you add them together. Make sure if they're going the opposite way, you subtract them. That's just how you do it. Okay, so let's this next section here. We have the 20 times the sine of 23, and then 20 times the cosine of 23. All right, I'm going to take a second. I'm going to punch these in my calculator, come back, and there'll be numbers there. Compare your numbers. Make sure they're right. I'll put positives and negatives on them also. Okay, I'm back, and let's just see what I did here. Now, when I look at my things, and I solved them out, let's first start down here. Let me get a pointing color. How about a nice orange color? So I made this a negative because it was going left. I made this a positive because it's going up. Negative because it's going to the left. Positive because it's going up. Positive because it's going up. Positive because it's going to the right. Positive because it's going to the right. Negative is because it's going down. Now make sure that you keep those in order because that makes a difference, right? If the vectors are pointing in the same direction, all to the left, they add together. If they're going all to the right, they add together. If one's right, one's left, they subtract. Up, add, down, add. Well, they're both negatives. And then if they're opposite directions, they're going to subtract from each other. So make sure you keep track. It's easiest just to go with that normal convention there with those. Oops, I got the wrong thing showing up here. All right, so what we're going to do is I like to put these into like a data table. Because if you put them into a data table, X and Y, and then you can put them in a nice straight line, and it's easier to add. So let's see what we got here. So we have X and Y. So let's start, and again, I'm color coding. Why am I color coding? Because it's easier for you to see me do it this way. We have negative 9.7. Our Y is positive 2.6. Switch colors, yellow. Our X, negative 3.4. Our Y, positive 9.4. Let's go to salmon. We have, positive 17.7. Positive 17.7. 45-degree angle. Makes it nice. Now we have our green. Our X is positive 18.4. I don't have much room there. I gotta squeeze it in. And then our Y is negative 7.8. All right, now all we have to do is find the sum of those, and we'll be ready for the next step. So I'm going to pause again, and I'm going to make sure I get this punched in right, and I'll be back with you in a second. Hey, okay, I did my addition and my subtraction there. I got the x's being positive 23, and I have the y's being positive 21. If I look at my triangle, and I can see that, hey, that looks about right. So we're going to say that's good. All right, now we need to redraw this triangle. Okay, so redrawing this triangle now. These are both positive, so that means the x is to the right, and so this side of the triangle is 23. And then the y is positive, so that's up. And again, I'm going head to tail. Always go head to tail. It's just so much easier. And that's 21.6, right? Positive. All right, resultant is R. This is what we're going to try to find angle-wise. So we're going to try to find those two things. Now, again, I could put my labels in here, check with your physics professor, see what they want you to do. Labels are always good. You can never go wrong with them. All right, so Pythagorean's theorem, we're going to go 23 squared plus 21.6 squared equals r squared. I like to write it this way, and then the square root of the r squared is going to be equal to our answer. Putting it into finding the angle. Oops. Well, there we go. I did find the answer already. Oops. I have 21.8 squared. I must have rounded different when I did this problem before. Let's just use it though. 32 newtons is going to be our answer. I'm a big time rounder, so sometimes my rounds don't match up. It's all good, right? Okay, so let's try to find our angle. So we have an opposite side, we have an adjacent side. So the inverse tangent of the opposite, which would be 21.6 divided by 23, will be equal to our angle. All right, and we'll punch that in. Let's see what that is. Again, I don't think I had to pause for this, but 21.6 divided by 23 equals, turn my iPhone sideways, inverse tangent or second tangent. I always say second tangent. I got 43.2 degrees, and that will be our angle. All right. That should take you through any kind of vector addition. Again, I like to break it down this way because right triangles are so much easier to use than using the law of cosines and sines, and I think you'll appreciate it. You can use this on any vector. Get them to the x and the y, so you can add the x's, and you can add the y's, and then you can break it down, Pythagorean's theorem, and solve for your resultant vector. All right, thank you.